All right, Ms. Stewart, here's another type of optimization problem. These are called root problems or
route problems.
Route or root. It doesn't really matter.
It doesn't.
Yeah. Classic kind of problem. So I want to get cable. Here's my house, right here, up in the woods. I want to get cable. And the cable company, they want to charge me, because this is how they are. Really, it's terrible. They want to charge me $3 to run the cable along the road, and it's a 500-foot road before you get to my driveway.
So $3 per foot?
$3 per foot.
Oh my gosh.
It's ridiculous. They want to charge me $3 per foot to run along the road, and as soon as they turn off the road and start coming up to my house, they're going to charge me $4 a foot. It's ridiculous.
That's crazy.
So I'm thinking, and for some reason they're going to let me decide exactly how to run the thing. I don't know why that would.
Well, at least they're throwing you that bone.
For some reason they're going to let me decide how to run it. So I'm thinking maybe I should have them run it like directly from the existing box right through to my house like that, because that's the fastest path. What do you think?
Well, it is the shortest route,
short, yeah.
But you're going to be paying $4 a foot that way. You might,
that's right.
Don't you want to take advantage of the cheap road
That's right.
for at least a little bit?
As soon as they come off the main road, they're going to charge me that. Yeah, so maybe I should have them run it like all the way along the road as long as possible, and then to my house like this, because that's like really the shortest distance on the most expensive, the $4 thing. What do you think?
I like that, but now I think your overall distance is as long as possible.
So I think I see where you're going, Stuart.
Maybe you can get something in between, a happy medium.
I think what you're saying is I should have them run it to some point, I don't know exactly where, but some point, and then at that point I'm going to have them kind of cut right over to my house. So probably it's going to look exactly like that.
I think that's brilliant.
Something like that.
So you'll have part of the time on the cheap road, part of the time on the more expensive woods, but you're going to optimize your costs.
So I would like to tell them at what point they should turn off the main road and start coming to my house to get me the cheapest service.
Fantastic.
And actually, maybe I'm going to call this distance X, because I'm going to be standing in my driveway and say, when you get a certain distance from my driveway, I want you to start cutting into the woods. I'm going to be watching.
I think you should.
So maybe I can come up with some kind of cost equation and then take the derivative, set it to 0, do all that kind of routine. I hope you're going to help me out.
I will help you out.
So let's see if we can figure out how much this is going to cost. Well, let's see. This distance right here, that doesn't seem too bad to figure out, because if this distance is x, this distance must be, you're supposed to help me out at this point.
500 minus x.
500 minus x. I hope that makes sense, right? The whole thing is 500. I'm just subtracting x. So this distance, which is 500 minus x, is going to cost me how much?
$3 per foot. So you want to multiply that by 3.
That's terrific. Now we're on the tricky part here. This distance right here, gee, I don't exactly know what that is, but you know what? I have a nice little triangle here, and I can use some of the Pythagorean Theorem. That's x squared plus 100 squared. Well, actually, I should say that's x, but if I want this, I can use x squared plus 100 squared equals this distance squared. So therefore, this distance must be the square root, and I'm going to write it here. This distance must be the square root of x squared plus 100 squared. A little bit tricky. You see what I'm doing, Stuart?
I see what you're doing.
Is that working?
That's so great.
And I know how much this costs. That is 4 times x squared plus 100 squared. So great. I got an equation. Now all I need to do is find the maximum or minimum in this case. It's an optimization problem. Hey, it's already in terms of one variable.
Oh my gosh, that's so great.
I don't even need a second equation.
How fantastic.
That's beautiful. So maybe I could just simplify a little bit. Got cost is 1,500. I'm just distributing this minus 3x plus 4 times, and I'm actually going to write this to the 1/2 power.
I think that's a good idea.
100 squared, plus 100 squared, that's 10,000, to the 1/2 power.
Beautiful.
Now I'm ready to take the derivative. Here I go. C prime is derivative of 1,500.
0,
it's gonna
baby.
be a piece of cake, all right? Derivative of negative 3x?
Negative 3.
Negative 3. The derivative of this guy, well, that's 1/2 times 4. Little chain rule action going on
We haven't
here.
done chain rule
Yeah,
for
I
a
know.
while.
1/2 times 4 is 2. All the stuff on the inside. I love how this calculus stuff comes up again and again. So here's the chain rule to the negative 1/2, right? Subtract 1
Very nice.
times the derivative of the inside. Just 2x. Derivative of that is 0. So this is the derivative of the inside. Remember how the chain rule works?
I do.
Derivative of the outside, derivative of the inside. Terrific. So I'm just going to rewrite this. Actually, I'm going to set it to 0.
Since we're looking for a critical point.
That's right. Negative 3. I've got a negative exponent here. I'm going to move this whole guy downstairs.
I always do that too.
Say downstairs? Okay. I think we've been through this downstairs, upstairs.
I think we
before.
have.
This is plus 10,000 to the positive 1/2. Upstairs I have a 2. So, I set it equal to 0. Now I'm just going to solve for x. So I'll move the 3 to the other side there. I have 3 equals 4x. This looks like a doozy, but I think we can do it, Stuart.
I think so too. You're doing a great job,
Thank you very
Mr.
much.
Haas.
Is that enough zeros?
10,000?
4 zeros, yeah. The 1/2 power. That's looking a little bit funny, but you know, I think if I multiply both sides by this denominator, that's at least like I don't have to have like a crazy looking fraction. What do you think? So I'm just going to multiply. I hate to say cross multiply.
I do too.
Yeah, but I mean, if I multiply this side, you see what I'm in this direction there, I think I'll be all set. So I'm going to squeeze it in over here.
Alrighty.
I've got 3 times x squared. You still got me?
I have you.
All right. 4 zeros to the 1/2 equals 4x. Looking all right?
Looking good.
I think I can divide both sides by 3. Why not? So
Why not?
divide that guy by 3. Divide this guy by 3. I think I'm going to need more space, Miss Stewart.
I think so too.
All right. All right, I hope you can follow this because there's a lot going on. I erased everything except for the original equation. So obviously I've taken the derivative. I'm on my way to solving for x. So I divided both sides by 3. Now how do I get rid of this stuff to the 1/2 power there?
Well, I guess you could just square both
Yeah,
sides.
that sounds like a good plan. So I'm going to square this side, kind of unsquare root it. So if I square this side, and I'm going to write it way up here,
Good idea.
I end up with x squared plus 10,000, right? I've squared this side, and it's a square. Now I got to square this side, so that's 4x over 3 times 4x over 3. That is 16x squared over 9.
Looking beautiful.
Right? Squaring the whole thing. 4x over 3 times 4x over 3.
Fantastic.
Almost there. These are doozies here, but I'm going to subtract x from both sides, x squared from both sides. So I have 10,000.
Well, you want to get your x's together.
That's all I'm doing. 16. I kind of like writing it like that. 16/9 x squared minus x squared. I can simplify this a little bit. Really, this is like 9/9 x squared. So 16/9 minus 9/9. How many ninths does that give me?
I think that's, 16 minus 9 is
7
7
yeah,
ninths.
it gives me 7/9. Thanks for the help. Okay. So I have 10,000. 16/9. Is that working all right? That's 9/9
Yeah,
really? So
absolutely.
this is 7/9 x squared. I'm
Fantastic.
going to multiply both sides. You're going to have to help me out here a little bit.
I will absolutely help you
Multiplying by the reciprocal,
with my
right?
amazing
By 9 over 7. Thanks very much.
skills.
So that's 90,000 divided by 7.
Should we just round to the nearest something at this point?
Sure. Go ahead.
All right, it's 12,857.14.
Okay. That equals x squared.
Beautiful.
Very
Why don't
good.
can we erase that little thing over there?
This thing? This thing?
Yeah.
All right. Yeah, you have me erase a lot of stuff.
I know, I'm
All
sorry.
right.
It's just now it's getting confusing when we're
Okay.
getting close to it. You're the best.
Yeah, thanks. Now what? You square root it?
I think we have to square root
I
both
think you better
sides.
square root that.
Okay. we have 113.4, let's say.
Okay, let's say that. Now what is, I think I'm done here.
I think you are. You found the
This-
x value.
this
Isn't
is
that what we
feet.
wanted to find?
So here I am standing in my driveway, and when they're going to be running it along the road. As soon as they get 113.4, that's important.
Yeah.
0.4 feet. I'm going to tell them, hey, that's far enough. Turn off into the woods here, and that's going to give me the cheapest path for the cable to run to my house.
That is very cool. Hey, if we wanted to actually find what the cost was, could we
Right.
do that?
Well, of course, sure. So now I can certainly, to find the cost, I have what x is. I can certainly just fill in 113.4 for my x's. A little bit of work, but
Yeah.
that will give me the overall cost, and that will be the cheapest. Hey, it's not going to be cheap to run cable. I mean, I'm certainly talking over $1,000 here to
Absolutely.
run that to my house, I think.
Thank you.